Hello, this is our first tutorial on general relativity. We are going to start with a simple tensor transform to try to get a basic understanding of how this works. We define a tensor in coordinates. We suppose that we have a rank 2 tensor in Cartesian coordinates given here in a matrix form. Now T could represent a stress tensor or a metric component, but it is symmetric for simplicity. Now we define a coordinate transformation. We notate by an angle theta. Now for this, the rotation matrix is given here. And, the new coordinates after this transformation will be x prime or x. So our transform law for the rank 2 contravariant tensor is given here. Now we apply a 90-degree rotation. We will let theta equals 90 degrees. So we will have this. Then we compute t prime rt t. Now we compute the rt by simply multiplying them out, and we get this form. Then for our step 2, we multiply by r to the t, so we get this. Now each component is here t1 t1 1 1 t1 1 2 and so on. These are just the components of each matrix multiplied together. Then you'll see these the little sub notation here. What 2 2 means, the second row and the second column. So 2 2 here is 2, and so on. Now the interpretation of this is that the original tensor rotated in a rotated tensor in new coordinates. This shows how the components of a tensor change under rotation, even though the tensor itself is invariant. The physics it represents does not change, which is easily generalized to higher coordinates, as we shall see. This is just because general relativity is a lot to do with transformations and tensor transformations. So this is like the very basic, try to build a very basic intuition. I will also show possibly Einstein's equations in matrix form and whatnot, and we'll try to give an insight into the Christoffel symbols, which can be very difficult to understand. But please do subscribe, I've got plenty more to come.